So now we've talked about the standard form of a circle. We've talked about the general form of the circle. It's time for us to talk about graphing circles. So let's graph some circles. This will be a lot of fun. All right. So starting here at this first example, graph a circle with the center -2, 3, and radius 4. It makes the most sense to start by graphing the center. So that's what we're going to do. We're going to graph our center at -2, 3. And then the radius is 4. So especially while you're doing this by hand, the best way to graph a circle is to use the radius to plot 4 additional points. One above, one below, one left, and one to the right. So let me use a different color just to show where the circle is going to be. We know that our radius is 4, so I can go 4 units to the left, right, up, and down and plot another point. So I went 4 units over, plotting a point. And I'm not going to leave that line in there. 4 units up, plot a point. 4 units to the left, plot a point. 4 units down, plot a point, and then you have yourself a circle. Don't worry, everything did not turn out okay. There we go. Boom, circle. That's how easy it is. Let's do another one over here. This worksheet, by the way, is available on our Canvas shop, so please download it. It's a lot easier to do this on a gridded paper. So our center is at 5, -1, plotting my center. The radius of this circle is going to be 3. So going up 3 units, plot a point. And when I say up 3 units, it's 1, 2, 3. That's why I'm only 2 units above the x-axis, but I'm 3 units away from the center. Then I'm going to go 1, 2, 3 units to the right, 3 units down, and 3 units to the left. Let's hope that this, yay, it works. Not good enough. And there it is, circle. Let's do a few more examples. All right. So for these ones, we have the equation of the circle in standard form. We need to find the center, the radius, and graph it. So I'm going to pull the center away from this. We have h is equal to -1. K is equal to 3. Remember, opposite signs. And r is equal to 5. So the center is at -1, 3. The radius is 5. Let's draw it. Plotting my center first, -1, 3. Then I'm going 5 units up, down, left, right to plot my circle. So 5 units to the right, 5 units up, 5 units down, 5 units this way to the left. Bam, circle. Over here, we have h is equal to 3. K is going to be equal to 0. Our radius is the square root of 36, which is 6. So our center is at 3, 0. And our radius is 6. Plotting my center right here. And it's the same deal with graphing the circle. We do 3 units to the right, not 3, 6 units to the right, so that's our radius. 6 units up, 6 units down, and 6 units to the left. And there it is. There's my circle. So I think I have 2 more problems to do on here. Let's go ahead and do them. So write the standard form of the circle that contains the point 2, 5 and has center -1, 5. Graph the circle. Let's take the information we have and kind of parse through it. Important, we know that the center is at -1, 5. -1, 5. So I can plot that, -1, 5. Here is my center. Now, there's other ways for us to find the radius. If we plot the additional point that we've been given, so it says the circle contains the point 2,5, and that means that the circle goes through the point 2,5. And here's the nice thing. If we were this lucky, which we are in this example, to have the points be directly horizontal from one another, we know this is the center, this is part of the circle. That means that this has to be the radius. This distance right here, this has to be the radius. Because if this is the center and this point's on the circle, the distance from the center to the circle is the radius by definition. So I can go ahead and I could finish this problem without doing any additional math and be done. I want to talk about what we would do if that weren't the case, though. So here is the answer. The center is at -1, 5. The radius is 3. Therefore, the standard form is going to be x plus 1 quantity squared plus y minus 5 quantity squared is equal to 3 squared, which is 9. This is the answer. But let's say we weren't as lucky. Let's say we were given this point right here. Now, I don't know if this point's actually on the circle because my graphing could be off. But let's say we were given a point like this where I can't tell easily what this distance is going to be. You could use the Pythagorean theorem. But if you were given a point like this where it's not horizontal or vertical directly, you would need to do a little more math. So the way that you would deal with that, if all you had was x plus 1 squared plus y minus 5 squared is equal to r squared, if you couldn't find the radius, you could take this other point that you've been given, the point 2, 5, and plug it in for x and y. So you could say x is equal to 2, y is equal to 5, plug it in for x and y in here, and then you're left with only one variable to solve for. Here's what it would look like. We have 2 plus 1 squared plus y is 5. 5 minus 5 squared is equal to r squared. This is 3 squared, so 9, plus 0. 5 minus 5 is 0. 0 squared is 0. So 9 plus 0 is equal to r squared. And sure enough, you get r equal to 3. So it works no matter how you do it. If you have them directly vertical or directly horizontal, it's a lot easier. But you can still do it even if they're not. All right, and finally, last one. The endpoints of the diameter of a circle are 2, 6, and -4, -2. Find the center, radius, and then write the equation of the circle in standard form and graph it. All right, there's a lot here. Because we're doing this on paper, it makes a lot of sense for me to just kind of graph it first. We have 2 endpoints of the diameter, which is more than enough for us to graph. Keeping in mind that when we're graphing on paper, we can't be certain. That our graphs are perfect. So we can't necessarily gather all the information we want off of the graph. We still have to verify it algebraically. But let's plot. 2, 6, we have a point on the circle here. -4, -2, we have another end of the circle here. And this is the diameter of the circle. We need to find the center, we need to find the radius. The center of the circle is halfway between the 2 ends of the diameter. Right? The diameter goes all the way across the circle. The midpoint is halfway between both ends of the diameter. I'll write it down. Just so happens that we have a formula for the midpoint of a line segment. So if we have 2 points, x1 comma y1 and x2 comma y2, the midpoint of those 2 points is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2, essentially the average of the 2 x values and the average of the 2 y values. So the center is at, and we can label these guys up here. This can be x1, that could be y1, x2, y2, and it doesn't matter which order you do them in. Okay, so we have 2 plus -4, x1 plus x2 divided by 2. We have y1, 6 plus y2, -2 divided by 2. 2 minus 4 is -2. -2 divided by 2 is -1. 6 minus 2 is 4. 4 divided by 2 is 2. So our center is at -1, 2. And that's really convenient because that's exactly where it ended up on my graph when I was graphing. So I feel good about that answer. Let's move on to the radius. The radius we can get by finding the distance between the center, which we just found, and any other point on the circle, which we have 2 of. So we can use the distance formula here. The distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And if you want more information on this, you can re-watch the video on the distance formula. So let's look at the points we have. We have the center at -1, 2. I'm going to choose this point right here, this 2, 6 point, just because it's easier to work with positive numbers than it is to work with negatives. So that's the one I'm going to choose. So the other point is 2, 6. So we have x1 is -1, y1 is 2, x2 is 2, and y2 is 6. I am plugging those values into my formula over here. And because I am lazy, I'm just going to go ahead and duplicate and do a little erasing. Let's hope I have enough space here. All right, x2 is 2, x1 is -1, so minus -1 is +1. y2 is 6, minus y1 is 2. Two plus 1 squared is going to be 9. 3 squared is 9. Plus 6 minus 2 is 4. 4 squared is 16. So we have the square root of 9 plus 16, which is the square root of 25, which is 5. So the radius of the circle, I guess I really shouldn't have called this D for distance. I'll call it R for radius because in this case, the distance formula was giving us the radius. The radius is 5. The center is -1, 2. We have found the center. We found the radius. We just need to write the equation of the circle and graph the rest of it. So center at -1, 2, radius equals 5. Standard form is going to be x plus 1 quantity squared plus y minus 2 quantity squared equal to r squared, so 5 squared, 25. That is all the pertinent information there. And then I'm just going to plot a few more points using the fact that our radius is 5. So I'll plot a point 5 units down. I'll plot a point 5 units up, 5 units to the right, 5 units to the left. And if everything is good and just in the world, bam, there it is. There she is. And that's how you do it. So that is all I have to say about graphing circles and just about circles in general. I hope you've enjoyed these videos. I know I love talking about circles. And I will see you in another video. Bye.